Okay, so I couldn't be there in class today, obviously, so I thought this might be the best thing I could do to kind of cover stuff because I've been looking at homework and we really struggled with some stuff in 5.4, and I know you're going to be struggling with some of the stuff in 5.5. So since I can't be there, I don't want to kind of have a weird day off. I want you to hopefully get something out of it. So I want to look over some stuff from section 5.4 first, and then talk about 5.5, and it's going to be a long video, but you know, what else you got to do? Anyway, so 24 from 5.4. The thing that you have to recognize is we're going to break this up, and there are two things going on. And again, and this is what a lot of you guys had struggled with. It seemed like in the homework. Well, there are two things struggled with. One was not recognizing what was the biggest operation going on. Second was not recognizing when to finish the problem. So you have to look at what's in the inside. It's x cubed y squared z. There's three things inside here. But what's happening to all of them? Multiplication between all three of them. That's what's happening, not the powers. Some of you guys are trying to pull the 3 out for the power first, the 2 out for the power first. No, that 3 is only over the x, the 2 is only over the y, the z is actually a first power. So what I can do first on 24 is actually split this up into 3 separate logs. Log a of x cubed plus log base a of y squared plus log base a of z. So I can split those 3 logs up. Now, some of you stopped here, and I really hope that's because you didn't understand it versus just being too lazy to go, oh, it's good enough for homework, I guess. Because this isn't complete. This would be 1 point out of like 3 on the test because you didn't finish the first and second part. They both have exponents, so those can go to the front. So now 3 log base a of x plus 2 log base a of y plus log base a of z. That's when you're done. When you've got everything separated that's being multiplied or divided, and any power over those terms once they've been separated have been moved to the front. So for number 28 then, we've got common log of 5a over 4b squared. Again, the first thing that's happening is you're dividing. So I'm going to split this up as log of 5a minus log of 4b squared. Now what I saw was this on a lot of papers. A lot of you guys did this. You knew separate them with subtraction. The problem is some of you just stopped here, which no, we still have stuff going on between 5 and a and 4 and b squared. And secondly, those of you that did do stuff, you were trying to take the 2 and move it to the front. No, that squared is only over the b. So before I can do anything with that squared, I got to separate the 4 and the b squared, and I can't stop here at 5a because those guys are being multiplied. So on the left-hand side, this should have been common log of 5 plus common log of a. And then on the right-hand side, split those up because they're being multiplied. Log of 4 plus log of b squared. Now I know we talked about this in class. You could distribute the negative to both of these, or you could leave it as a quantity separated. It's generally okay either way. But these two are being multiplied together, so I need to add their logs. This negative does make them both negative, though, to cover the division of both. But then I got a power over the b. That's got to go to the front. Okay. So log of 5 plus log of a minus log of 4 plus 2 log of b. Now, next one to take a look at is 32, because this was another one that a lot of you guys struggled with. So looking at everything, again, if you were looking at 32, and again, if you haven't got your book out real quick, I think it's Mrs. Moffitt supposed to be the sub today, so hi, Mrs. Moffitt. No comments, Jacob. Pause it and get your books out real quick if you haven't already. But the thing going on here is there's division. Okay, yes, there's division, but actually more than anything, there's this cube root over everything. So this is really log base c of y cubed z squared over x to the 4th, all to the 1/3 power. Now this is where I move the 1/3 to the front before I do anything, because the cube root over everything. So 1/3 log base c of y cubed z squared over x to the 4th. Okay, and now basically we're back to that previous problem was split up the division, then split up the multiplication, bring the powers down. But the whole way through there's this 1/3 in front. So the easiest way to get around that is just put 1/3, put a bracket, and just start breaking this stuff down. Treat it separately if the 1/3 is not a part of it, but by putting it in the front. So you have so you have log base c of y cubed z squared minus log base c of x to the 4th. Okay. Now I can split this up. Okay, with addition, because again, those are being multiplied together, so split those logs up. Now that I've split the logs up, now I can take the powers and move them to the front. So I get 1/3 3 times log base c of y plus 2 log base c of z minus 4 log base c of x. Okay. If you want to distribute the 1/3, you can, because it would be 1/3 and 3 would cancel to 1, so you just get log base c of y, but then you get 2/3 of this and 4/3 of that. So this is a perfectly acceptable problem to leave that way. Alright then. Now condensing. Yeah, condensing. This one. Okay. Two things. One, before I can deal with the subtraction, I have to deal with the coefficients. And those coefficients were once powers, so those need to move up to the top. So it would be then log base a of x to the 2/5 minus log base a of y to the 1/3. Now, I also saw on some people's paper, on one paper, and I can't remember who it was, so and I wouldn't call you out like this anyway in front of everybody, but one person then said, oh yeah, this is a radical, which is true. A fractional exponent's a radical, but you cannot say this is the 2/5 root of x. That is not what this means. What this means is the 5th root of x squared, or the 5th root of x quantity squared. So it's just leave it to the 2/5 power, that's fine. Okay. Now that I've got division, I'll write it as a single log, and this is what a lot of people, they struggle with it. I don't care what class it feels like you teach it, no matter how I say it. Some of you will still do this. You're condensing it to a single log. That's the point. So you should only write log once. It is not log of a of this divided by log base a of this. No, it's log base a of x to the 2/5 divided by y to the 1/3. Okay, because remember, these are exponents, and you subtract exponents when you're dividing them. But we're not dividing the logs. We're dividing the arguments inside the logs. That's when I subtract their exponents. So that's it. Now the monster one that a lot of you missed, and that's why I want to look at it, was number 50. Okay. Now, some of you are trying to bring the 2/3 in here first. Don't. This is division. Deal with this division first. This is 2/3 times the natural log of x squared minus 9 over x plus 3. Then plus natural log of x plus y. Now hopefully you caught that, hey, wait a second, that's x squared minus 9. Oh, that's x plus 3, x minus 3. Hey, when that's over x plus 3, those cancel. So this actually becomes 2/3 natural log of x minus 3 plus natural log of x plus y. And then before I can bring those two together, I have to bring the 2/3 up. And now that I'm adding the two logs together, and they're the same base, both base e, I can bring it together as one single log, and this will be x minus 3 to the 2/3 times x plus y. There's our most condensed log. But again, I still had some of you doing log of this times log of this. No, I'm not multiplying the logs. I'm multiplying what's inside the logs. And inside is an x minus 3 to the 2/3 and an x plus y. Okay, so there was a bit of a mini rundown of section 5.4. Here is the rundown of 5.5 from yesterday. So I'm going to try to move through these, but as you can see, we're already about 10 minutes in, so I probably got about 30 minutes left. Again, it's going to be a slog, but you got a weekend to do your homework, so nah. Anyway, 7. So this one, I can rewrite them at the same base. Okay, 7 is one we can rewrite at the same base. So 125 is 5 cubed. Okay. So now that I've got that, I've got 5 to the 4x minus 7 equals 5 cubed. Now set those exponents equal to each other because the bases match. Add 7. You get 4x equals 10. Divide by 4. X is 5 halves. And I could check it, but I don't need to. I know this one works out okay. Now 11 is the case where I can't write the bases with the same number, so this is where I've got to take a log. And again, I can take any log I want. I can do log base 84 if I wanted to, or I could do log base 17. So the one way is to take log base 84 to both sides, or to rewrite it as a log. So it's log base 84 of 70 equals x. That's an answer that's acceptable. Then you could do your change of base formula, natural log of 70 over natural log of 84. Get your decimal approximation. The other way is, once you've got, go to the beginning, 84 to the x equals 70. Take the natural log of both sides. Okay. This x will drop to the front. Sorry for the bad handwriting. So natural log of 84 equals x times natural log of 84 equals natural log of 70. Divide by the natural log of 84. There you go. There's your answer, which is the same thing as the change of base formula. So I don't personally care which one you use. Either answer is fine. This one isn't as useful because it's not ready for decimal. This guy here, though, I could just get out my graphing calculator and go, okay, natural log of 70. Whoops, turn you on. Natural log of 70 divided by natural log, not common log, natural log. Natural log of 84. And we get to 4 places, which is what they tend to want for this. 0.9589. There we go. There's our approximate answer. All right, so that's kind of the basic, ideas. Either you write them with the same bases and then set the exponents equal, or take a log, or just rewrite it in the definition of log with the definition of log. Now, where we can't do that, we can with 15. Sorry, I'm trying to look ahead here. With number 15, no we can't. Strike that, no we can't. 15 and 21 are ones where we can't just rewrite it as a log. You have to take a log to both sides. I know 15 doesn't stand out very well in the copied, but but you got it in front of you in the book. What I'm going to have to do is I've got e to the negative c equals 5 to the 2c. Now we didn't look at one like this, but we covered it close enough. This base is e, this base is 5. So I could take log base e to both sides or log base 5. I could choose either one. I'm going to choose log base e because, as you can see on my calculator here to the right, it's built in at natural log. Doesn't point, whatever. So natural log of both sides. Negative c moves to the front. 2c moves to the front. So I get negative c times ln of e equals 2c times ln of 5. Now, natural log of e, that's 1. Okay. So I have negative c equals 2c times ln of 5. Okay. And then what I'll have to do is add a c to both sides. And then I can take a c out of both sides. And I get 2 ln 5 plus 1. Well, the only way that's going to equal 0 is if c equals 0. So yes, this is one of those annoying cases where you did all that work just to get c equals 0. Now, number 21 will not work that way. Okay. Because the exponent's got a little more going on. So you got 3 to the x equals 2 to the x minus 1. So again, you can take any log you want. I tend to take natural log. 1, it's 2 letters. And 2, we use it more often in science. So now the x drops to the front, so does the x minus 1. Okay. So now I get x ln 3 equals x minus 1 times ln 2. So what I'm going to have to do is on the right-hand side, distribute the ln 2. Which gives me x ln 2 minus ln 2. Subtract x ln 3, subtract x ln 2 from both sides. That gives me then, when I factor out the x, natural log of 3 minus natural log of 2 equals negative natural log of 2. And now I can divide by natural log of 3 minus natural log of 2. So x equals exactly negative ln of 2 over ln of 3 minus ln of 2. And if I want that as a decimal approximation, clear, negative ln 2 divided by, open up parentheses, close parentheses, divided by, open up parentheses for the denominator, ln of 3, close parentheses, minus ln of 2. And that gives us negative 1.7095. There we go. Now number 29 then, next one. 29 was one of the trickier ones because it was this solving a quadratic formula problem that has e to the x in the problem. So first of all, the first thing you have to realize is you've got 2 e to the x equals 5 minus 1 over e to the x. And now I'm going to multiply both sides by e to the x, or basically every term times e to the x. And what that gives me then is 2 e to the x to the 2x equals 5 e to the x minus 1. And what we'll do is move this to the left side, move this 1 over. Okay. And like in class, this doesn't factor, unfortunately. So we're going to have to use the quadratic formula. So I'll do off to the side here. So x equals the opposite of b, which is 5, plus or minus the square root of b squared, which is 25, minus 4 times 2 times 1, so minus 8, all over 2 times 2, which is 4. And remember, this is really actually e to the x. I'm actually solving for e to the x, not x. So e to the x equals 5 plus or minus the square root of 17 over 4. So e to the x equals 5 plus square root of 17 over 4. E to the x equals 5 minus root 17 over 4. And then to solve for x, take the natural log of both sides. So x equals natural log of 5 plus or minus root 17 over 4. I know this is okay. I don't have to worry about checking it because remember, we can't take the log of a negative number. I know it's not negative because 5 is root 25. Root 25 is bigger than root 17. So both of these work. All right then. Now, out of the exponentials for a little bit, into the logs. Take a drink of tea. So, log base 2 of 10 plus 3x. Now this one, again, if with the log ones, get the log by itself. Get log base something of something equals something. I know it's a lot of somethings. But log base 2 of 10 plus 3x equals 5. And the reason is, you could do 2 to both of those and get this to cancel off. That's what's happening. The easier way to think of this, though, is just simply 2 to the 5th, which is what this states, equals 10 plus 3x. So 2 to the 5th is 32. Subtract 10 now. Divide by 3. X is 22 over 3. And if I check it real quick, 22 over 3 is positive. This stays positive. It's going to be okay. 39. 43. 43. Now this one, I've got log base 2 of x plus 20 minus log base 2 of x plus 2 equals x. So this is subtraction, meaning I condense this to one single log. Okay. Equals x. And now since these bases match for both the logs, the insides match. So now to solve this equation, multiply both sides by x plus 2. That gives us x plus 20 equals x squared plus 2x. Subtract an x, subtract a 20, get it equal to one side because now we're solving a quadratic. X squared plus x minus 20. That factors to be x minus 4, x plus 5. Okay. And that gives us then that x equals 4 and negative 5. But of course, we have to check our answers and make sure that we don't get extraneous solutions, or in this case, don't get negatives inside the arguments for the log. Well, negative 5 will do that for us. So negative 5 is extraneous. The only one that truly works is x equals 4. And these becomes 24, 6, and 4. And 24 over 6 is 4. So there's our answer. Okay, next one. Number 47. Number 47. Same exact problem. Okay, you've got common log of x equals common log of x plus 4 equals common log of 12. So again, you've got that addition. So this is really a single log of x times x plus 4 equals common log of 12. Well, now since these are both logs, they match. So it's x squared plus 4x equals 12. So I can ignore these. And now move the 12 over. This factors be x plus 6 times x minus 2. That gets us x equals 2 and negative 6. And then again, we run into the same issue of, oh, if I plug negative 6 in for x, I get negative inside the log. So I can't use negative 6. Only one I can use is 2. Number 51. It's kind of getting repetitive, but yeah, why not? 51. Those guys are being added together, which means they're being multiplied. So log base 4 of x plus 3, x minus 3 equals 2. So when I multiply those together, that's actually x squared minus 9 because they're difference of 2 squares. But now I can rewrite it. X squared minus 9 equals 4 to the second power when I rewrite it from its log form to its exponential. Base to the power equals the argument. So x squared minus 9 equals 16. Add 9. X squared equals 25. Take the square root. X is plus or minus 5. However, when we check the negative 5 back in up here on top, negative 5 plus 3, negative 5 minus 3, blah, that ends up giving us extraneous, so it's just x equals positive 5. Oh, actually, I didn't realize it here, but yeah, last one. Number 57. Now, this one, I picked because little work to be done here, in the sense that I have to add this to that side first, actually. I've got to get the logs together if there's two logs on separate sides, and that's it. Got to get them together as one. So this is really log base 6 of x plus log base 6 of x minus 5 equals 1. Now I can get those guys together as a product. And now base to the power equals the inside. So 6 to the first, and this is just x squared minus 5x. Subtract a 6. And then we have to factor one of the most commonly missed problems I see all the time in factoring. X squared minus 5x minus 6. Everyone wants to say negative 3, negative 2. Well, negative 3 times negative 2 is positive 6. This is actually x minus 6, x plus 1. That's how it factors. So, I get then x equals 6 and negative 1. Again, though, negative 1 fails that part there. I plug it in, I get a negative on the inside. So, only one that works is 6. X equals 6. Now, this is not all of section 5.5. Okay, there are more problems you had for homework, but I think I kind of hit everything. And really, I'm running to the point where if you haven't lost your attention completely, awesome. You probably have. So you'll have some extra problems to do after this over 5.5 and 5.4. for a bit of review to make sure you're on top of things. And then, yeah, that's it. I'll see you on Monday. And if you have any questions, do come in Monday morning because no one else has homework besides you. So, yeah, come on in.